The next problem said that there is a hanging copper cylinder at the top of a steel wire of negligible mass, which top end is fixed. When the wire is struck, it emits a sound with a fundamental frequency of 300 Hz. We know that the density of copper is equal to 8.94 grams over cubic centimeters. And we need to find the fundamental frequency when the cylinder is submerged half of its volume in water. Also, we know that the density of water is equal to 1 grams over cubic centimeters. For solving this problem, first we need to make the free body diagram. In the first case, we have tension 1 and the weight. In the second case, we also have the tension 2, the weight, and the buoyant force. Now that we have the free body diagram, we need to make the sum of forces in Y to have two equations. But first, we know, thank you to Archimedes' principle, that the volume displaced is equal, for example, in this case, to the density of the liquid, of the water, times gravity times volume. In this case, it's half the volume because the cylinder is half submerged. And that the weight is equal to the density of the copper times gravity times volume. And also in this case, it's density times gravity times volume. Now we can make the sum of forces of Y equal to 0. And we got the tension 1 is equal to mj. That is the weight of the cylinder. And by substituting, we got the tension 1 is equal to the density times the gravity times the volume. In the second case, we got tension 2 minus the weight plus the force equals to 0. So the tension 2 is equal to this. Then we substitute. And we get these two equations. Now we see our formularium, and we know that the velocity is the square root of the tension force over the mu, and that frequency is equal to velocity over the wavelength. We substitute the velocity in this formula and we got this. So, in order to obtain the frequency, we need to eliminate unknown data by dividing the frequency 2 over the frequency 1, which give us this big formula. So we can eliminate lambda, the mu, and we isolate the frequency 2, and we get that is the frequency 1 times the square root of tension 2 over tension 1. And because we already obtained the equations of tension 1 and of tension 2, we can substitute them in this formula, and we get that frequency 2 is equal to frequency 1 times gravity volume over we got this. We also can eliminate data, and we remain with this simple calculation. We substitute the values we know. The frequency 1 was 300 Hertz. The density of the copper was 8.94 grams over cubic centimeters, minus the density of the water, it was 1, divided by 2, and all these divided by the density of the copper, and we finally obtained that the frequency 2 is equal to 291.4 Hertz.